Scientific notation is a number written in this form, where A is a number at least 1 but less than 10, and B, the exponent, is an integer. So for example, if I have this number written in scientific notation, that is actually 2.5 times, and 10 to the third is 10 times 10 times 10, or 2.5 times 1,000, which is 2,500. There's a shortcut for writing numbers in standard form. You start with the 2.5 and then you move the decimal point 3 places, and in this case it's 3 because this exponent is 3. 1, 2, 3, making the number larger, and you fill in zeros as needed. So that new decimal place is here, and in standard form that number is 2,500. So 2.5 times 10 to the third power equals 2,500. Scientific notation, standard form. The exponent is positive, and when you have a positive exponent, you're going to have a number greater than 1 when it's written in standard form. All right, let's look at another example. Well, this time the exponent is negative, and what that means is you have 3.6, and then that's times 1 over 10 to the third. So really what you have is 3.6 and then divided by 10 to the third, or 3.6 divided by 10 times 10 times 10, 3.6 divided by 1,000, or 0.0036. Notice that in scientific notation, if the exponent is negative, once you've written the number in standard form, the number is going to be less than 1. It's a small number. Using the shortcut, again, if we start with the 3.6, we're going to make the number smaller, and we're going to move the decimal place 1, 2, 3 places. Here's the new decimal point, and we add zeros as needed. So 0.0036 is standard form. All right, let's look at starting with standard form and going to scientific notation. So for example, if we start with 25,000, that's standard form, and if we want to write this in scientific notation, the first thing we need to do is add our decimal point. It would be there. And we want our new decimal point to go here between the 2 and the 5, because we need a number that is at least 1 but less than 10. And then that's going to be times 10 to the, and we count where our old decimal place is, and we count how many spaces, 1, 2, 3, 4 to the new decimal point. And that's a positive exponent because our original number, 25,000, was a large number. It was a number greater than 1. All right, let's do another example. Okay, here's a number written in standard form. It already has a decimal point. Our new decimal point to write this number in scientific notation would need to go here, because we need a number at least 1 but less than 10. So we have 8.36 times 10 to the, and we count how many decimal places we've had to move our decimal point. 1, 2, 3, 4, 5. And this time our exponent is negative because our original number was much smaller than 1. It was smaller than 1, so it would have a negative exponent when written in scientific notation.